Hi, welcome to Mathematics with Tom. I'm Tom, and today we're going to make what's called a frequency distribution from our histogram. This is the same histogram that we used in the previous video, and it's the histogram that results from this data set. So if we need to reference this, I'm just going to reference, for now we'll just call it data set. This is the data set. This is the corresponding histogram, and I want to label a few things. We said that our horizontal axis, we called this the class boundaries. Call these the class boundaries, and our vertical scale was the frequency. We'll write it this way. That was our frequency. So the histogram, in this case, we have the distance, the width, if you will, of these bins. We call these our classes. And so this is a class, and it's the class from negative 0.5 to 1.5, and it has a width of 2. And so that meant that what we did is that any one of these data values that was either a 0 or a 1 was then put into this bar. So this is a pictorial representation of this data set. Histograms are also, this is a visual presentation. Now we're going to put this information into a table format. So let's do that. And when we put it into a table format, we call it a frequency distribution. So that's what today we're going to talk about. Histogram to a frequency distribution. Frequency distribution. Okay. So here's what our frequency distribution looks like. We're going to start out with the most basic one, and then we're going to add a few columns, and I'll explain those as we go. So if we just make one directly from our histogram, we're going to have two columns. We'll have a column for our class boundaries, and we'll have a column for frequency. So, but I'm going to make this with some foresight. So here we go. So the first column on my table will be class boundaries. Class boundaries. Now, leave a space. We're going to be putting another column in here. And actually, we'll put it in now. It's called class limits. The next one is going to be a tally. And we'll show you how to use that when it's time. But that's another one that might be on there. And your next one will be frequency. And the last column will be a cumulative frequency. Cumulative frequency. All right, here we go. Our class boundaries, well, they're right here. So let's write these down. So our class boundaries are from negative 0.5. I'm going to use a long dash so it's a little different than my negative sign, to 1.5. Then it goes, this boundary here then is from 1.5 to 3.5. So 1.5 to 3.5, 3.5 to 5.5, 5.5 to 7.5. Okay, I might have done those a bit fast. We're just taking these, so here's our 1.5 to 3.5. It's the vertical boundary of our classes. And then our next one is this line is from 3.5 to 5.5. Our next boundary then goes from 5.5 to 7.5. And our last boundary starts here at 7.5, and then it ends at 9.5. 7.5 to 9.5. Okay, I'm going to put a line under all this. Next, the next thing that we have here is the frequency. Our first class has a frequency of 5. So over here, I'm going to come over to try to keep my horizontal lines aligned. So my frequency is 5. My next class from 1.5 to 3.5 has a frequency of 12. So let's record that. If you're using lined paper, you don't need to make these dots, and I'll erase those. It's just to keep my alignment here. So 12. Then my next from 3.5 to 5.5 has a frequency of 8. Okay. The next class from 5.5 to 7.5, if we come up here, we go to the top of the bin, we look over and we're at 6. So we have a frequency here of 6. And then our last one from 7.5 to 9.5, go to the top of the bin, we come back to the vertical axis, we see that we have a frequency of 9. Frequency of 9. Now, right here, this is the most basic frequency distribution. We have class boundaries and we have frequency, and that's really all we need. Now, we're going to add a little bit to this. We're going to take a look at our other columns. I think the next one that I want to do can be done in one of two ways. If you were making a frequency distribution, what you want to do is you want to make sure you haven't made a mistake in your counting. So let's come back to our data set. And notice this. Notice that our data set has 1, 2, 3, 4, 5, 6, 7, 8. And every column is nicely aligned. So every row also has 8. And there's 1, 2, 3, 4, 5 rows. So 5 times 8, we have 40 data values. So in other words, when we come back to our frequency distribution, our frequency here should also total 40. If it doesn't, we know we have made a miscount somewhere, and so then we can correct. So let's add this up. 5 and 12, that's 17, plus 8 is 25. 6 more would be 31 and 9, and that would be 40. And right off the bat, we know we were correct. Okay. Another way we could have done that is actually recorded that arithmetic that we just did. And we would do that in our cumulative frequency column. So the cumulative frequency says, all right, we bring over this first column, we've looked at 5 data values. By the time we get to the second class, how many data values have we looked at? Well, we've looked at all of the data values in our first column, plus all of the data values in our second column. So we looked at 5 plus 12 more. So this next column is the 5 plus the 12. Well, that's 17. And then I'm going to just put here on the right, we usually don't put the work, but you could just, for the sake of remembering, this is the 5 plus the 12. The 5 from the previous bin, the 12 from the current bin. Now let's look at the next one. So our next one is from 3.5 to 5.5. But at that point, we're talking about our cumulative beginning at the minimum. Well, from 3.5 to 5.5, we've looked at the first two bins, but we already know how many is in there. Plus the amount of data in this third class, which is 8. So here's what we're doing. We're going to take the 17 that we've already used, plus we're going to add to that 8 more. And so by the time we've looked at the first 1, 2, 3 classes, we have looked at 17 plus 8, or 25 data values. And if we continue this, our next class is going to be 6 more. When we've looked from 5.5 to 7.5, we've looked at all of the data in the first 3 classes, plus the data in the 4th class. So we would add another 6. So this is going to be a 25 plus 6 more data values for a total of 31. And when we look at the last class, this green column, we've looked at now all of the data values from the very beginning to the very end of our data set. And at that point, we add the 31 plus the 9 that are in that rightmost column, and we see that we're at 40. Again, it's another check to make sure that we've actually accounted for all data values once and only once. No, we didn't miss one and we didn't double count one. Okay. Now, the next two, let's look at class limits. I think this is one of the more subtle distinguishing points. So let's come back to our histogram because I need to put some dots back in place. And I'm going to put the dots back into one of my bins to explain. And you may remember that there was a 0 and a 1 in here. And our data set had 1 dot over 0, and it had 1, 2, 3, 4 dots over 1. And then if we looked at our next bin, and let me double check here at 2. At 2, we had 5 more dots. We had 5 dots. Now, here's where the class boundaries, remember, we deliberately put them between data values. We didn't want a class boundary to split dots. No dots die while making histograms. So that's what the boundaries indicate. They indicate that no data values fall on the boundaries. It's like the fence line. The class limits move inside of the boundaries, and they look at the lowest data value to the highest data value in that class. So in this case, our class limits are from 0 to 1. In the next bin, my class limits are from 2 to 3. In my next one, they would be from 4 to 5. And notice that the boundaries share an overlap, but that overlap doesn't contain any data values. Class limits do not overlap, and here's why. If a class limit was to overlap, for example, from 0 to 1, from 1 to 2, then what would happen is we would have a double counting in the values between 1 and 2. So to avoid that, there's no overlap in class limits. So our class limits fit inside the boundaries. So here they are. Our class limits for our first class are from 1, oops, not 1, it's my mistake. Let me fix that there. Are from 0 to 1. From 2 to 3. oops, let me get rid of those dashes, from 4 to 5, from 6 to 7, from 8 to 9. Okay. Now here's another piece that we need to be careful of. Our class limits, remember the width of our class? The width of our class is 2 units, from negative 0.5 to 1.5, or 2 units from 1.5 to 3.5. And if you subtract 3.5 minus 1.5, you get a class width of 2. But if you subtract the classes, you won't get the correct, if you subtract class limits, you won't hit the correct class width. So it's a subtlety to be aware of. Okay, so we have one more column. One more column. Okay. The tally. We didn't use the tally. We didn't need to use the tally. But here's what the tally would have been. The tally would just be if I didn't have my histogram. If I didn't have my histogram, what I would do is I would say, oh, here's a 3. So I would come over here and say, oh, my 3, there's a 3. And then I would make sure I recorded that, and I'd go to the next data value and say, oh, there's a 1. I'd come over here and put a tick mark here in the 1. And I would continue that process all the way through. And in this case, I would have had 1, 2, 3, 4, 5 tick marks in the first one. I would have had 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 tick marks in the next class. Would have had 8 tick marks. 1, 2, 3, 4, 5, 6, 7, 8. Oh, and here's another thing. When using tick marks, the standard convention is that the fifth tick mark always is the one that crosses them out. So it's easy to get distracted, and I've seen people put 4 and I've seen people put 6. A group of tick marks with a slash represents 5 data values. So for the number 6 in tick marks, it would be 1, 2, 3, 4, 5, 6. And 9 in tick marks would have been 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And that is how you make a frequency distribution from a histogram. I hope that helps, and thanks for watching.